This is it, the most important chapter in the entire course for a senior interview. If you take away only one topic at full depth, make it this one. Here's the plain truth. If you're strong on RMAN, archive log mode, and recovery scenarios, you will stand out from every other candidate because a shocking number of people are shaky here. Backup and recovery is the DBA's most sacred duty. It's the difference between a bad day and a resume-ending catastrophe. So we're going to go a little longer and a little deeper. We'll cover what RMAN is, the vocabulary, a real strategy, the restore versus recover distinction, and the what would you do if scenarios interviewers love. Let's earn the offer. Let's start with what RMAN is. Recovery Manager RMAN is Oracle's built-in tool for backing up and recovering databases. Now, you could, in theory, just copy the data files yourself with an operating system copy. So why does RMAN exist? Because it understands the database, and that changes everything. It knows which blocks are actually in use, so it can skip the empty ones and make smaller backups. It can detect block corruption while it's backing up, so you find problems early. It tracks everything it has ever done in a repository, and it can perform smart, automated recovery from those backups. A dumb file copy does none of that. So the message to deliver in an interview is simple and confident. Serious Oracle shops back up with RMAN, not with manual file copies. A few terms come up constantly, and being fluent in them is what lets you describe a real strategy instead of hand-waving. First, two formats. An image copy is a bit-for-bit copy of a data file. It's identical to what you'd get from an operating system copy. Its advantage is that it's already a usable file, so restoring from it is fast. A backup set is RMAN's own compact format. It bundles one or more files together and skips the unused blocks, so it's usually noticeably smaller than an image copy. So the trade-off is roughly space versus restore speed. The backup set saves room. The image copy is instantly usable. Know both words and what each optimizes for. Next, the words that describe how much you back up. Full versus incremental. Now scope, how much you back up. A full backup captures all the used blocks of the files it's backing up. An incremental backup captures only the blocks that have changed since a previous backup, which is what makes daily backups dramatically smaller and faster. You're not recopying data that hasn't moved. Then there are levels, which people mix up, so get this straight. A level 0 incremental is a full baseline that incrementals build on. Think of it as your foundation. A level 1 incremental captures the changes since the last level 0, or since the last level 1. So the pattern is, lay down a level 0 baseline, then take small level 1s that record only the deltas. That vocabulary, image copy, backup set, full, incremental, level 0, level 1, is your toolkit for describing any strategy. Before any strategy, the prerequisite, and this is where Chapter 10 pays off. You cannot do meaningful recovery without a history of changes, so almost everything in this chapter depends on the database running in archive log mode. Archive log mode is what allows online, or hot, backups, taken while the database is open and serving users. And it's what allows recovering up to the exact moment of failure, or to a chosen earlier time. In no archive log mode, you're limited to cold backups taken while the database is shut down, and you can only restore to the moment of that backup. Everything after it is lost. State this dependency clearly and confidently in an interview, because saying, "This all assumes we're in archive log mode," shows you understand the whole chain, not just isolated commands. Here's the distinction candidates blur most, and getting it right instantly marks you as experienced. Restore and recover are not the same thing. To restore means to copy backup files back into place, replacing what was lost or damaged. To recover means to apply redo, the archived and online redo logs, to those restored files, rolling them forward to a consistent current point in time or to a chosen earlier one. See why you need both? Restore alone gives you old files from last night. Recover then replays every change since to bring them current. So the textbook response to a media failure is, restore the data file from the latest backup, then recover it by applying the archived logs. Say both verbs in that order: restore, then recover, and you sound like someone who's actually stood at the console and done it. Interviewers love asking you to describe a backup strategy, so here's a clean one you can deliver out loud. Run the database in archive log mode and send both backups and archived logs to the fast recovery area. Take a weekly level 0 baseline and a daily level 1 incremental. That keeps daily backups small while always having a recent full foundation. Back up the archived logs and the control file too, because you need those to recover. Set a retention policy, for example. Keep enough to recover to any point in the last 14 days, and RMAN will automatically mark older backups obsolete and reclaim their space. And the line that shows real maturity: periodically run backup validate or restore validate to prove your backups actually work, because an untested backup isn't a backup, it's only a hope. Let's linger on the pieces that make a strategy self-managing. The fast recovery area from Chapter 7 is the one managed home where your backups, archived logs, and control file auto backups all land. The retention policy is the promise you make about recovery, most commonly a recovery window, like, I must be able to recover to any point in the last 14 days. And obsolete is the flip side. Any backup that's no longer needed to satisfy that window gets marked obsolete, and its space is reclaimed automatically. Put those three together and you see why the FRA basically runs itself. You give it a size budget and a recovery window, and RMAN continuously keeps it tidy, keeping what you need, discarding what you don't. That's the elegance of the design, and it's great to articulate. Now the headline commands. You connect with RMAN target /, often using that sys backup privilege from Chapter 11, so the backup operator doesn't need full sys DBA. The core verbs, backup database or backup database plus archive log to grab the logs too. List backup and report obsolete to see what you have and what's aged out. Restore and recover to bring data back, remember, both verbs, in that order. Cross-check and delete obsolete to keep the repository honest and reclaim space. And validate to test that a backup is actually usable. Here's the reassuring part. You do not need every option memorized. You need to know the verbs and what each one is for. If you can say, I'd back up with plus archive log, then restore and recover to fix a failure, and validate to test, you've demonstrated command of the tool. A multi-tenant angle that ties back to Chapter 2. In a container database, you can back up at two levels. Backup database, from the root, backs up the whole CDB, the entire building. Or you can back up a single PDB with backup pluggable database and the PDB name, just one apartment. Why does this matter? Because different tenants might have different needs. Maybe the sales PDB is critical, and you back it up hourly, while a dev PDB only needs a nightly. The pluggable database granularity lets you tailor protection per tenant without touching the rest of the building. Mentioning backup pluggable database shows you can apply RMAN thinking to modern 19C multi-tenant, which is exactly the kind of connection that impresses. Now, the part interviewers enjoy most, the scenarios. Scenario 1. You lose a single data file, a disk hiccup, a corruption. This is the everyday case. And the beauty of it is how surgical the fix is. You restore just that one data file from the latest backup, then recover just that file by applying the archived logs, and in many cases, the rest of the database stays open and serving users the whole time. You only take the affected tablespace offline, fix it, bring it back. The commands are literally restore data file, then recover data file. Notice the shape of the answer, because that's what matters more than exact syntax. Restore the one file, recover the one file, minimal downtime. If you can describe that calmly, I'd isolate the affected file, restore it, recover it, and keep the rest of the database up. You sound like someone who's handled it before. Scenarios 2 and 3. 2. You lose all your control files. Because you configured control file auto backup, which you did as part of a sensible strategy, you restore the control file from its auto backup, then recover the database. That's the whole reason auto backup of the control file matters. It's your escape hatch from an otherwise unstartable database. 3. Someone makes a bad change across the whole database, a batch job runs amok, a mass update goes wrong. Here you'd use point-in-time recovery to rewind the database to just before the mistake, or if it happened recently and the window is small, you reach for flashback, which is literally the next chapter, and the meta point, the trap. You do not need every command memorized. You need the shape of each answer, what you restore, what you recover, and which tool fits the situation. Let's watch a real RMAN session end to end, because seeing the rhythm makes it click. You connect with RMAN target /. You run backup database plus archivelog, and it captures the database and the logs. You confirm with list backup summary, which shows your backups with their type, level, and tag. You tidy the repository with report obsolete and delete obsolete, reclaiming space per your retention policy. And you finish with validate database, which proves the backup is restorable and reports 0 corrupt blocks. That's the peace of mind step. Backup, confirm, cleanup, validate. That's the daily rhythm of protecting a database, and being able to narrate it shows you don't just know the commands, you know the workflow. That's exactly the fluency that separates you from someone who only read about RMAN. Let's lock in the big one. RMAN backs up the database because it understands it, it skips empty blocks, detects corruption, and tracks everything in a repository. Vocabulary: image copy versus backup set, full versus incremental, with a level 0 baseline and level 1 deltas on top. Everything depends on archivelog mode, which is what enables hot backups and point-in-time recovery. The distinction that marks experience: restore means copy files back, recover means apply redo to roll them forward. Say both verbs, in that order. And for scenarios, know the shape. Restore and recover a single file with minimal downtime, restore the control file from auto backup, and use point-in-time recovery or flashback for a bad logical change. That last idea, a fast, lightweight way to undo human error, is exactly where we go next. Chapter 15, Flashback.